Okay, 5.1. The first thing we're going to try to do is find the greatest common factor. And we've already done that with numbers. Let me get where you can see it here. 5.1. Okay, your first thing is finding the greatest common factor. You know how if you had like a 12 and 15. When you were finding the greatest common factor, the first thing you were doing was saying 12 has the factors, it's like 3 times 4. Or if you took it all the way down to the prime factorization, it would be 3 times 2 times 2. And then 15 was 3 times 5, right? What do they have in common? The 3. So the greatest common factor was just 3. Okay. If we had the number 8 and the number 32. 8 is 4 times 2, or if you did the prime factorization, it would be 2 times 2 times 2, right? Okay, 32 would be 8 times 4. Okay. 8 was 2 times 2 times 2, and 4 was 2 times 2. Okay, what you would do is you would get the most numbers, the 2 shows up. The most times it shows up is 3 of them. So your greatest common factor is 2 times 2 times 2, which is 8. Okay, we've already done greatest common factors before, or you did it in another class. But now we're going to be doing it with letters also. Okay, if you have x to the 2nd power and x to the 3rd power. X to the 2nd power is x times x, and x to the 3rd power is x times x times x. What do they have in common?
X.
2 x's, right? They have 2 x's in common, which is
X to the 2nd power?
x squared, right? Sorry. This is kind of weird. Come in, come down a little bit where the whole page will be on. Okay, now let's do it with numbers and letters. The greatest common factor of 4x to the 5th power and 10x to the 3rd power. So you're going to need to find the greatest common factor of 4 and 10, and then you'll need the greatest common factor of x to the 5th and x third. Okay, 4 would be 2 times 2, 10 is 2 times 5. What's the greatest common factor of these?
2.
Just 2, right? So that's part of your greatest common factor is the 2. And x to the 5th and x to the 3rd power. They have 3 in common, right? So x to the 3rd power would be the x part of it. Okay, there's some kind of long, crazy ones. Let me show you one like that. How about 16 P5 Q3 and 32 P3 Q2 and negative 48 Okay, let's just do the letter part right away. How many P's do they have in common? You have 1, 3, and 5. You're gonna have 1 P here, 3 P's, and 5 P's.
3.
Does this one have 3?
One.
They all just
That
have
only has
1. See, there's 1 here, and there's 3 here, and there's 5 here. So they all just have 1 in
One.
common. So let's do the 1 P here. So it's really the smallest of the letters. See how it was 3 and 5? It was the smallest one. So on the Q's you have 2, 3, and 4.
So it's only 2.
The smallest one.
Oh, 2.
2, 3, 4. Yeah, the 2. Okay, now the numbers. Can you tell by looking at these that 16 goes into 32 and 48? If you know that 48 is a multiple of 16, you could just put 16 down. If not, you might have to prime factor them. Because this is 4 times 4, or 2 times 2, 4 times. And then 32 would be 16 times 2, so it's 1, 2, 3, 4, 5. Okay? The 48 is, you might know it as 2 times 24, or 4 times 12,
Or 12 times, yeah.
2 times 24, or, okay, 2 times 24, and 24 is 2 times 12, and the 12 you could divide into 2 times 6. You want the easiest way instead of doing this way like this?
Going up, right?
Going up. 48 divided by 2 is 24, divided by 2 is 12, divided by 2 is 6, divided by 2 is 3. So we got 1, 2, 3, 4 2s and 1 3. 1, 2, 3, 4 2s, and 1 3. So see, they all have at least 4 2s. If you multiply 2 times 2, 4 times 2 is 8, times 2 is 16. So the number part would be 16. Okay, I think that's enough for greatest common factor. Okay, now we're going to start factoring different terms, okay? We're going to be factoring. Okay, factor. If you have x squared minus 6x. Okay, what is the greatest common factor of an x squared and a negative 6x? They both have what in common?
So X has the 1.
Yeah, so 1x here and 2x is there. They both have at least 1x, right? As far as the number part, you don't need to factor any numbers out because 1 is your greatest common factor of the number part. So the only thing we can factor out is an x. We're going to put it on the outside of the parentheses. And now for each term that we have here, we only have 2 terms. But for each term, we're going to have something inside of our parentheses. Okay, x will be multiplied by what to give you x squared? X times x is x squared. Now you need the minus. X times what will give you 6x?
6.
Yeah, x times 6, right? So we factored x out. We divided every term by x. And if you actually multiply this back, it's still going, isn't it? Oh, it's not still going. It looks like it stopped.